Okay, we're gonna change this up a little bit. I'll show you real quick how to convert it. If you get this number right here, you're gonna have to end up converting it into square feet if you want to get this number. That number, you would have 12 inches in 1 foot, and you're gonna have to do this 3 times to convert it to cubic feet, because that would be feet cubed. Okay, so you're going to end up dividing by 12 3 times if you get this big number. That's assuming your calculator will put that big of a number in it. Let's do this problem where we can get it in cubic feet, and it'll be a lot easier. We're going to take the same pipeline. The 48 inches was the diameter, so the radius is 24 inches. And we've decided maybe we should go to feet on both of them. So 24 inches is 2 foot. Just 2 feet. Okay? The 800 miles, we had that converted into feet earlier. Oh, we had it converted into inches. Let's just do 800 times 5280 and just go to the feet. So what's 800 times 5280? It's how many feet there? Somebody?
4,224,000.
4?
Yeah.
0, 2, 2.
4,224.
0, 0, 0. Okay, that's how many feet. Okay, now this should be a lot quicker. The volume is pi r squared times the height. The pi, 3.14. The radius, 2. That'll be a lot easier than the 24. 2 times 2, and the height is this number. 4,224,000. So if you still have that in the calculator, do that times 4 times 3.14. Did you get this number here? Almost? That's because they... Okay, 5.
5, 3, okay. So start
53.
0, 53.
440. And why do you think it didn't come out exactly the same? Right, they used the pi button. We used 3.14, so it came out smaller. And these are really big numbers, so it made the difference from 80,000 to 53,000 here. So that's a pretty big difference, but yeah. The engineers probably use the pi button because they need to be accurate. Okay, that was number 10A. Okay, 10B says you want to estimate the amount of material needed to construct the pipeline. Okay, the material would be the outside of it, which is the surface of it. Are you going to need the surfaces of the circle, the ends? Let me show you. Are you going to need the surface of this circle and this circle?
No.
No, you're not going to have it plugged off, right? So all you need is the what's called the lateral area, your outside area. Surface area, you have the formula 2 pi r squared plus 2 pi rh. This part right here is your 2 circles. See, here's a circle. That's the 2 circles. You don't need this part of the formula. You don't need the 2 circles, so you're just going to need this part. That's your lateral area. So we're going to do 2 times 3.14 times the radius, which we figured out was 2, and the height is 4,224,000. So go ahead and multiply that all out, and it'll probably be smaller than the book because we're using 3.14. While you're doing that, I'm gonna write down what the book has. What did you get for these numbers? Huh?
I got the same answer.
The book got the same answer also. It's probably because we're using the same numbers. Yeah. Because we're multiplying the same numbers here. See, on this one, the height was the same, the radius was the same in 3.14. So it's the same thing. 2 pi r. This is, the 2 here was the same as the radius. That's why it came out the same. The radius and the 2, this was the radius times the radius.
So if we were gonna cover the ends, it would have been 2 pi r squared plus.
You would have added the 2 circles, right? It would have been a lot bigger.
Different.
Right. Right.
Cover the ends.
So the book got the same answer as it did for the volume, but this is actually surface area. This is what you need for how much material you need. This is how many square feet of material. This is not volume this time. This was cubic feet. This is square feet. And the engineers would have got a closer number than we got. The book says you need this much area fabric. And that's your last one. 2 points.